Hey everybody, I'm Nick here, and welcome back to Human Resource Machine. We're gonna go to the mod module this time, and we're gonna do it good. Now, if you're not familiar with the mod, it's a mathematical operation, kind of, that basically is give you the remainder. If you remember doing long division, it sometimes ended up with a remainder, obviously, if it didn't divide evenly. That's basically what mod does. Good thing we have these optional night shifts to cram in more. For each 2 things in the outbox, the remainder that would result had you divided the first by the second. Don't worry, you don't actually have to divide, and don't worry about negative numbers for now. So basically, we're going to do 5 mod 3. 5 mod 3 says divide 5 by 3 and give me the remainder, which is going to be 2. Because 5 goes in one time. So, how are we going to do this? Well, let's talk about it. So, we're going to inbox 5. We are going to copy it to 0. We're going to inbox 3. And we're going to copy it to 1. We are then going to... then we're going to enter our loop. This is going to be our loop. So, we are going to say subtract. So, right now we have the 3, so we subtract 0. If it's positive, we keep going. But we actually need to copy it to 2. So this is the its. This is what we're iterating on. This is the mod. % sign is used as the operator for mod usually, and this is going to be the last. Because what's going to happen is when we go negative, we're going to have some interesting things. So we're going to sub it, right? And if negative, that's when we're going to do stuff. Specifically, we're going to copy from the last one and outbox. What this will do is... this loop isn't quite done, by the way. We copy and we store. We subtract this from this. In our first case, it'll be 2 right away, but that's not negative. That means we haven't tried to divide. Because remember, we created multiplication by by adding the same number together multiple times. You can divide by subtracting one number from the other and counting the number of times you do it. It's because division and multiplication are inverses of each other in terms of operations, it makes sense that those flip-flop the way that they do. But this is kind of the same thing, except when we go negative, then we know we have a problem. Because that means we've gone 1 too far. And whatever we would have had left over is our remainder. 0 is going to be an interesting case. It's already solved, but I will run through it at a certain point because we have an example right here. So we're going to subtract from what's being iterated on. And then if it's not negative, we're going to copy it to the last. And then we're going to copy from this because we need to get our modulo back. So let's go ahead and step through this. I don't know if it'll work, but we're going to find out. Alright, so let's put it here. We copy from the inbox. Or we inbox. We copy to the it. We inbox. We copy to that. Cool. We subtract. Darn, it's subtracting the wrong way. Crap. Okay, this isn't going to work. So we actually need to copy from it and subtract that. This actually makes things a little bit easier. We also need to copy it to last, just in case. we do need to do it. So, you know, that's the thing. So, because this case is actually going to do that. I want to double check. Outbox the remainder that would result if you divided the first by the second. So 8 divided by 2 is going to be our first one. So we should get 0 for that. So, we copy that to last, and then we copy... Actually, we don't have to. We don't have to do that anymore. Okay, that actually might have saved us some effort here. So we inbox. We copy it there, and we copy it to our last. We inbox. We copy it to percentage. Then we copy from it. Okay, we subtract this. It's not negative, so we copy it to last. Subtract there. It's not negative, we copy to last. Alright, and here's where 0 happens. Oh, it's negative, so we copy from last, and we outbox. And then we jump. 8 and 4. Okay. That's normal. We should then end up with another 0, because this would be -4. Cool. Okay, here's where it's going to get interesting, because this is our initial condition. This is why we have to do this right here, this case right here. Because we drop 4 into last, and then we grab our divided 8. So 4 eighths already doesn't divide evenly. It's not even going to divide once. So we pick up our thing, we subtract. It's negative, so we copy from last, and there we go. So we're dividing 0 by 7. So our remainder is going to be 0. Beautiful. So that worked as planned. Now we have to optimize. We are 1 command too long. This is actually if we can optimize both. Okay, I think there's got to be there's one command that's too much. Which one is it? It's probably one of these. We need the initial condition. Don't we? We don't. We don't. We do not at all. Interesting. I think we don't at all. Yep, we don't have to. Because we are... I just noticed that we were never interacting with this, except for the first time that we started, because we're just bouncing back and forth between the two. So we should actually hit the optimization on both of these exactly. Fantastic! I wasn't expecting to solve that earlier because it's over here. So we're going to do the cumulative countdown then. What is the purpose of this assignment? I think it's something about calculating the volume beneath staircases. We have to put the interns somewhere. That's terrible. Alright, for each thing in the inbox, outbox the sum of itself plus all the numbers down to 0. For example, if the inbox is 3, the outbox should be 6 because 3 plus 2 is 1. Awesome. This is going to be a use of bump. So we're going to inbox. We are going to... Ah, darn it. This is going to be our number. This is 0, and this is our total. Awesome. So, we do need to copy from 0 and copy to total. We have to set our initial conditions for the loop. We then inbox and we copy that to number. That is our initial conditions. We have everything set up exactly the way we want to. Actually, we're going to go ahead and do this. Because our first one is going to be our first one. So then what do? We bump that. if negative, we are going so when we bump down to 0, actually, jump if 0. Crap. Well, let's do this slightly differently here. There's a 0 here, so if we do a jump if 0, it's going to break there, which is unfortunate. So right now we're just going to jump if negative, and I'm probably going to guess that our optimization is going to center around the fact that we have a 0 as a possibility. Maybe. We'll find out. So we're going to bump it, because we've already added it in. If it is 0, or if it's negative, if it is 0, it will be bumped to negative, and we'll know that we're done adding stuff. Which means that we will then copy from our total, outbox, and then loop back. However, if it is not negative, we are then going to add it to the total, copy it to the total, and then do it again. I actually think this is good. So let's check it out. Let's increase our step speed here. We're in inbox, so 3. We start with 3, we bump it to 2. It's not negative, so we add it to total, we copy it to total, and we jump. Okay. We bump number. It's not negative, so we add it to total. We copy it to total. We jump. We bump. It's 0. Okay, and then we bump it negative. We copy from total. Oopsie. That's my bad. Alright. Okay, here we go. This is where we want to be. Jump if negative. Copy from total, outbox. Cool. So this is going to take some time. 4, 3, 2, 1. Alright. It's negative. Copy from total. So this works. This definitely works. But it's not going to be optimized, I think. For a couple reasons. But primarily the whole 0 is the case here. Cool. This is exactly what I expected. We made something really efficient here, but it's not very efficient in terms of number of steps. That's okay. We can fix that. Basically, what's interesting is we could do a jump if 0 here, and make this also a jump if 0. This removes the issue. This entirely removes the issue. Because we jump if 0 here. The only reason this would ever have been negative is if we had started with a 0. Because we bump number down before we check it, ever. So if we jump if 0 here, then this will never be negative, so we can jump if 0 here. That reduces the times that we go through here by 1 for every single execution that isn't 0. And it skips all of it for every execution that is 0. So let's see how this runs. You'll notice that this... I mean, this is still taking forever, but we're still getting the right answer. Oopsie. That is my bad. Yeah, because jump if 0 outbox. That is my fault. I placed that the jump wrong. So we might actually get a double optimized answer. Maybe, I don't think so. I think there's some more optimization. Nope, I was wrong. I mean, we could probably optimize this better, but I guess we're gonna get to do a third puzzle. A third puzzle in one episode. That's usually unlikely. Remember last time when I told you didn't need to divide? Well, now you get to. Okay, this is actually going to be fun. All right, for each two things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers. Divide by 0 or remainders. This might be a good time to practice copying and pasting from a previous assignment. Don't care. So how many times the second one goes into the first? So we're going to have to copy from 0 and copy to, and this is going to be our answer. It is very hard to write like that. Alright, so that's our answer. We are then going to inbox. We're going to copy that to... Oh gosh, I can't remember the proper names for the parts of division. So this is our number. I suppose we can do numerator, if you think about this as a fraction. And I'm just gonna go denom and num, so you can read it. Numerator, denominator, is that right? Yes. So we copy to num, we inbox, and we copy to denom. Now, it's worth noting that we are purposely ignoring remainders, dividing by 0, and negative numbers. We don't have the code to deal with those, actually. Kind of. We could do it, but it would be really, really ugly. Divide by 0, obviously, we don't have an undefined output, so we couldn't do that. Negative number, we technically could, but it would require kind of like a little bit of the state machine type thing we did before, where basically we say, hey, is our first one negative? Is our second one negative? Okay, it's going to go to your answer is positive. And basically it would lead to two different algorithms that when we divided, we'd have to be subtracting or adding appropriately. It would be really messy, and that's why they're not having us do it. Just because we don't have the commands to do it properly. And I'm totally okay with that, turns out. Alright, so we've set up our answer. Copy from 0. Copy to answer. So we set up our initial conditions because we're going to be bumping this. So, comma numerator, copy to denominator. Alright, so this is where stuff gets interesting. So we're going to be subtracting the denominator from the numerator. So we actually have to copy from numerator. Then we have to subtract the denominator. If the answer is negative, shenanigans will occur. That's when we copy from the answer, outbox, and loop all the way back. If it's not negative, we bump the answer. Yeah, well, not quite, actually. First we copy it to the numerator, then we bump the answer. And then we have to jump back to here. And I actually think this might work. This will be really cool. So basically we set up our initial conditions by storing everything where it needs to go. We then take the numerator, we subtract the denominator. If it's negative, that means that we've divided it as many times as we can, and there will be possibly a remainder, but it doesn't actually matter, we're ignoring those. And then we get our answer. Otherwise, we copy it to the numerator, so we store back what we've already subtracted, and then we basically say, hey, we subtracted 1 from it by bumping the answer up 1. So basically at any point in time, the denominator times answer plus what's left in the numerator will equal the original number. And I'll stop at some point to show you that that's true. So we set up our initial conditions. Cool. We copy from the numerator. Subtract the denominator. It is not negative, so we copy that to the numerator, and we bump the answer. So you'll notice this was a 9. 2 times 1 plus 7 is 9. And this will hold true, I think. So 2 times 3, 6, plus 3, 9. Subtract, oh, we're negative. So we copy from answer and we outbox it. I think we're good. We do have a 0 case that I'm going to want to look at, though. Okay, this is the case that I want to see. Alright, so we've got 0 and 7. We copy from the numerator, we subtract the denominator. Okay, and it worked just fine. We are wasting 2 right here, which kind of sucks. Booyah. No! No, we did it! Oh my gosh, we did it in the first one. That's dumb. That's awesome. That's dumb. I guess we go back to the other. Do we do one more? Do I do 3 sort? I think we do 3 sort. I think we can get it done. I think we can get it done. I have no idea what it is, but I think we can get it done. Yes, we rank all our employees here from worst performing all the way up to best performing. What? Where do you rank? Let's give it some thought while we complete this assignment. For each 3 things in the inbox, send them to the outbox in the order from largest to smallest. Oh, hell yes. Okay, so, holy crap. This is cool. Okay, so, no, we can't even name that right. Okay, so here's what we're gonna do. We basically have to pick one, and this is the fun part. This is a state machine, weirdly. Basically, we need to find the, we want to find the biggest one first. Oh gosh. Okay, this problem is going to span the next episode, but let's see if we can get it solved by this one. I don't think we're going to get an optimization done. I do like that they gave us the initial condition. That's the initial condition that's being set up. All our code happens afterwards. I'm going to remove that jump. So, there's like, I'm trying to think of the different ways we can do this. So there's a couple. The first one that jumps to me in the most obvious sense is compare each set of numbers, each pair, which is 3 comparisons, and whichever one wins twice goes on, right? And is next, and then you compare the last 2 and flip-flop. That'd be the easiest way to do it. There's also some other really shenanigans ways to do it, but I don't think I want to do that. Basically, it would involve bumping all 3 of them. Like using bump minus. When one of them hits negative, you keep bumping, but then when the second one hits 0, you know the order. It would be really complicated, but it would be awesome. I kind of want to try that one, but I'm going to do the first one first. I think that's going to be closer to the correct answer. The bumping one is just kind of silly. But it just occurred to me that it might work. So, we're going to compare these. So, largest. So what we do is, so we're going to, we're going to have A, B, and C. So we are currently holding on to C. So we subtract B. So we've got jump if negative. So, we're subtracting B from C. So if it's negative, we've got B larger. We're kind of doing a state machine here. If it's not negative, then C is larger. If C is larger, then we copy from C, because we have to get it back, and then we subtract A. If B is larger, we have to copy from B, and then subtract A. So, then we have a jump if negative, and this, so if we're subtracting A from C, and it's negative, then A is largest. A largest. Which means that we are going to copy from A an outbox. We'll get to what happens afterwards. We'll get there. In fact, we're actually going to do it right there. Otherwise, if it is negative, wait, Whoopsie. I did this wrong. We're subtracting A from C. If it's negative, A is largest. Here is C, largest. So if C is the largest, then we copy from C an outbox. Now, if B is larger, we copy from B and we subtract A. If it's negative, that means A is the largest. See how convenient that is? And otherwise it means B is largest. I'm getting better at this, but it's still not great. And if that's the case, then like others, we copy from B an outbox. So, what happens then... Excuse me. We've got our A largest, C largest, A largest, and B largest. So we have to deal with what happens after all of these. So we then have to compare B and A. Which is, you know, fun, I guess. Because we wanted to output the largest first, right? Oh, from smallest to largest. Crap. No! Okay, we want to do smallest to largest. That is actually rather unfortunate. I made this mistake. Ooh. So we actually need to find the smallest. So let's start over. So, not entirely over. We're gonna modify things as we go. So we subtract B. If it is negative, it does mean that B is larger, but that means we want to copy from C and subtract A. If that makes sense. Otherwise, C is larger, so we want to copy from B and subtract A. So that means here we're not actually comparing C being largest anymore. We copy from B, subtracting A. If it's negative, that means A is larger. So B... Okay, actually, we need to stop thinking about it like this. I don't want to think about larger. We want to think about smaller. It's not a huge distinction, but I think it's big enough. So, subtract B from C. If it is positive, that means B less than C. We're just going to do that. So then we copy from B, because we need to get B back. We subtract A. If it's positive, that means A is less than B. And we know that B is less than C. I believe. Because we know B is less than C to be here. So we copy from B, subtract A. We know this to be true. So we copy from A, outbox, copy from B, outbox, copy from C, outbox. Great. I think that all works. It's the other case that gets a little wonky. So this jump, if negative, I'm gonna use this to delineate this being a thing, but this jump, if negative, might not be correct anymore. So if it is negative, that means B is bigger than C. So this goes here. So it means that C is less than B. So then we copy from C, because we want C now, and we subtract A. If it is not negative, that means A is less than C is less than B. So then we copy from A, copy from C, copy from B. Hopefully this is all making sense thus far. Oh, wow. If you double click on this, it adds it to the bottom. Now, if it is negative, that means that A is greater than C. All it means is that A is greater than C, and this so I believe in the last case these merged together here. I think that might still happen. So first off, at the end of this, we jump. At the end of this, we jump. Because those are now solved states. But if we... So this jump, if negative... there's so much code. So this is going to explode in a couple cases, and we need to find those cases. So right now, this is pretty solid. So we know that B is greater than C. Or sorry, that C is greater than B here. So it's blank BC, or it's BC. We don't know where A falls in there in terms of ordering from smallest to greatest. If A is greater than B, we do not know about A and C though. So this might not actually fall in the same place. So let's... So if that's the case, we know B is less than C, and we know that A is greater than B. B is less than C, B is less than A. We don't know about C and A. I'm okay with that. This jump, if negative, is... We know C... Yeah, this has to move. This goes here now. We know that C is less than B. And we know if it's negative, that means C is less than A. Yes. So these almost overlap. We know B, we know C. So, yeah. This isn't going to be pretty. This is so many lines of code. Alright, as I said, I just want to get a solution on the table. So, we know that we are going to copy from C and outbox here. So then we copy from B and we subtract A. Because we haven't done this before, because we did C and B. Yeah. So, we copy from B and subtract A. So if it's negative, if it is negative, it's negative, that means that A is greater than B. So we copy from B, outbox, copy from A, outbox. Otherwise, we copy from A and outbox, and then copy from B and outbox. Oh my god. This is a problem. So many lines of code. So many lines of code. I'm curious what their benchmarks are going to be. Alright, so here, we're basically going to do the exact same thing. So we know we're going to copy from B an outbox. We know that. We know there's going to be a jump from here to the start also, at the very least. So we copy B and we outbox. Then we copy from A, and we sub C. If it's negative, I'm just building this up so that I can focus on the logic. Alright, so we copy A, we C. So if we subtract C and it's negative, that means C is greater. So that means here we're copying from A. Yes, that's right. And outboxing, and then copying from B and outboxing. If it is not negative, that means that C is smaller than A. Whoopsie. That should be a C. Copy from C, copy from A. Okay, this should work. In some hellish world, this should work. So let's watch it. There's basically gonna be 6 cases, which is the order. So we're gonna do this like as fast as possible. Alright. 3. So we subtract. Jump if negative. It's negative. So this is telling us that C is less than B. Great. So far our label, this is gonna work well for debugging. So then we copy from C, we subtract A. If it's negative, we know that C is less than B, and we know that C is less than A, but we do not know A and B in relation to each other. Great, that works. Right, so we copy from C, we outbox. Then we copy from B, we subtract A. If it's negative, we know B is great. Now all our initial conditions. 1, 6, 7. Is it negative? No. So we know that B is less than C. Beautiful. That is correct. So we copy from B, subtract A. It is not negative. So we know that A is less than B is less than C. Beautiful. Negative numbers shouldn't mess with anything. We have some equal ones, which isn't going to mess anything up either. It's just going to fall through a little bit differently. It's not negative, so we know that B is less than C. Really, it should be less than or equal to. I'm not going to change it just yet. So we copy from B, subtract A. Oh, you assholes. No, never mind. It'll still work. So it's negative, so we know that B is less than C, and B is less than A. Okay. It's true, technically. Less than or equal to. Okay, so it worked there. So we jump if negative. It's not. It's not. So A is less than B is less than C. Okay. It worked. And now we get to fail. Oh my god. Hey! Speed challenge achieved. Okay, so now all we have to do is the size challenge. And here's the thing. The size challenge is going to be dumb. But we're going to save it till next time, because this episode has gone a little bit longer than I expected. But we accomplished like 3.5 puzzles. And I would say 3 2/3, because getting it working is 1/3 of the battle. The other 2 optimizations are the other 2/3. So yeah, we've got to cut this down from 60 to something reasonable. But we will do that next time. But until then, keep your gears turning.